Because for IMFs, your biggest decision is my molecule, is it a polar molecule? Because remember, we care about the molecule. Or is it a non-polar molecule? Please don't say bond, because if you say bond, it's wrong. We have moved on from bonds now. We know that it's a covalent bond. So you can only move over to intermolecular forces once you know it's covalent, and you decide if it's a polar molecule or a non-polar molecule. If it is a polar molecule, you've got two choices. If it is a non-polar molecule, you've only got one choice. So you smile because there's really no option. Non-polar. Non-polar, guys. Non-polar means that those electrons are evenly distributed. I'll share the video with you that we played for the Form 3s. It's actually very cute. The electrons move, and then for a split second, remember there are electrons everywhere. And then for a split second, they might be more on this side, because remember they are moving at the speed of light. So now they're more on this side. Because they're more on this side becomes a little bit negative temporarily. And this side becomes a little bit positive temporarily as well. And what does it do to the electrons? If this is negative, what does it do to the electrons moving around here randomly? Push them away, and they move across to this side, which means this side becomes delta negative and this side becomes delta positive. And what does a positive and a negative do with each other? Attract. But very important, this one is called the temporary dipole, and you must be able to explain how these things come to be about. Temporary dipole, and this one is called an induced dipole. And where is the London force? Yeah, yes, between the positive of the one molecule and the negative of the other molecule. There is where I have my weak. You don't have to say weak, but if you say it, it reminds you that it's the weakest one. Weak London, IMF. Always for a non-polar molecule. And then if it's a polar molecule, you've got two choices. All of these molecules have a permanent delta positive and a permanent delta negative. So it's going to attract the delta positive of the next molecule permanently. Okay, so it is already, you can already see that it's stronger than London. So there, in between these two there, I have a dipole IMF. And then, so I said you only have one choice, so they're all going to be dipole, but then there's a special one again that needs to scream at you. Okay, so then if you have, so you have two choices, dipole or hydrogen bond IMF. When is it going to be a hydrogen bond IMF? So this is going to be a dipole as well, but now the H side is a stronger delta positive, and the NOF side is a stronger delta negative. And you need to know the reasons why. It is a small atom with a high electronegativity. There's a whole little thing in your book on why this is stronger. Learn it for the exam again. So we still have a delta negative on my NOF side, and I still have a delta positive on my H side. And I still have, I know the time is up, I still have an H bond, but that H bond is there between the two. Okay, and that is IMFs.